Hello everyone, this is from class 8 optional math exercise 5.3 question number 3. Prove the following identities. So in question number A we can see we have sin A plus 2 cos A divided by sin square A plus 2 sin A cos A is equal to cosec A. So from this equation we are going to solve this question. So let's see. Let's go from solution. The question is very easy. We have LHS sin A plus 2 cos A whole divided by sin square A plus 2 sin A cos A. So we'll keep the numerator as it is and we'll take common in denominator, that is sin square A and from sin A. So let's write the numerator same as it is, sin A plus 2 cos A divided by what we have common here, sin A. Sin A is common, so what is remaining, sin A plus 2 sin A dot cos A. Sorry, here we don't have to take the sin A because the sin A is already over here, so we'll take only cos A. So now you can see in numerator we have sin A plus 2 cos A, in denominator we have sin A plus 2 cos A. So the both can be cancelled by 1. So we'll cancel this sin A plus 2 cos A, sin A plus 2 cos A by 1. So what is remaining now? We have 1 by sin A. We have 1 by sin A. So we know that 1 by sin A is equal to cosec A. 1 by sin A is equal to cosec A, and this is our RHS. Very easy question. So for question number B, we will go to next page. In question number B, we have sin theta divided by sec theta, the whole divided by cos theta by sin theta. So this division will be writing in the form of fraction. Yes. Again, this question is also very easy. So we have to prove again LHS and RHS. So what is given in LHS? It is sin theta divided by sec theta, the whole divided by cos theta divided by sin theta. So now this division sin theta divided by sec theta will write in the form of fraction in this way: sin theta by sec theta, the whole divided by cos theta by sin theta. Now we know very well that when there is division between two fractions, so one fraction will be reverse, or we can say inverse, the numerator into denominator and denominator into numerator, and this division sign will change into multiplication sign. So we can write sin theta divided by sec theta multiply by, now this sin theta will go to numerator and this cos theta will come to denominator. Okay, so let's write what we have in our hand now. We have sin theta as numerator, we will write sin theta divided by cos theta. So now what we can do, we will be multiplying numerator with numerator and denominator with the denominator. So sine theta into sine theta, we have sine square theta. We have sine square theta divided by sec theta into cos theta, that is equals to sec theta dot cos theta. Now we can again cancel sec theta into cos theta by sec theta is equal to 1 by cos theta multiply by cos theta. Now you can see here we have 1 by cos theta multiply by cos theta. That means we can cancel this cos theta by 1. So what we have in our hand? We have sine square theta by 1, that is equals to sine square theta. So this is our RHS equals to RHS. Proved. So we can easily prove that sine theta divided by sec theta, the whole divided by cos theta by sine theta is equal to sine square theta. So for question number C, let's go to next page. In next page, question number C, you can see that sine theta multiplied by cos square theta plus sine cube theta is equal to sine theta. So when we solve this equation, we must get in RHS sine theta. How? Let's see. Solution, we'll write LHS, very easy question. LHS is given sine theta dot cos square theta plus sine cube theta. Now see, we have here one sine theta before plus and sine cube theta after plus. That means we can take sine theta as common. We are taking sine theta as common. So what is remaining bracket? We have cos square theta plus sine square theta, and you know very well sine square theta plus cos square theta is equal to 1. So we can write sine theta in bracket we have 1. So when we multiply this sine theta into 1, we will get sine theta itself, and this is our RHS. Yes, so it is equal to RHS. Proved. So we can easily say that sine theta plus cos square theta plus sine cube theta is equal to sine theta. Easy. So for question number C, question number D, we will see in the next. Have sine theta dot cot theta plus sine theta dot cosec theta is equal to 1 plus cos theta. Again, this question is very simple. What we'll do, we'll convert this cot theta in the form of cos by sine, and we'll be converting cosec theta in the form of 1 by sine. So let's solve it. Solution, in LHS it is given that sine theta dot cot theta plus sine theta dot cosec theta. As we have already discussed that we'll be converting this cot theta and we'll be converting this cosec theta. So let's do it. We know that cot theta is equal to cos theta by sine theta and cosec theta is equal to 1 by sine theta. So in this place of cot theta, we'll be writing this formula: cos theta by sine theta plus sine theta will write as it is, multiply by, we'll use this formula, 1 by sine theta. Now you can see sine theta multiply by cot theta, and cot theta is equal to sine theta cos theta by sine theta. Now you can see this sine theta and this sine theta can be easily cancelled out by 1, and this sine theta can be easily cancelled out by 1. So what we have in our hand remaining now? In remaining we have 1 into cos theta, that is equal to cos theta, and sin theta into 1, we have only 1 left over here, that is equal to 1. So we know that it is 1 plus cos theta, and it is our answer, equals to RHS. So the answer was very easy. Question was very easy. So now let's go to another question, and next question. Number E, we have 1 minus sine square alpha dot cosec square alpha is equal to cot square alpha. Again, this question is very simple over here. Let's solve it by solution. We know that, let's see here. We know that sine square theta plus cos square theta is equal to 1. So now cos square theta is equal to 1. This sine theta, when it comes to this side, it will be the minus sine square theta. So 1 minus sine square theta is equal to cos square theta. So we'll be using this formula over here. Okay, so let's write LHS. Given 1 minus sine square alpha multiply by cosec square alpha. So we have already discussed 1 minus sine square theta is equal to cos square theta. In the same way, 1 minus sine square a is equal to cos square a, and this multiply by cosec square a. And again in question number B, we have discussed that cosec square theta is equal to 1 by sine square theta. So we will be using this formula over here. Again, cos square alpha multiply by 1 by sine square alpha. So now we will be multiplying cos square alpha into 1, that is cos square alpha, and in denominator we have sine square alpha, that is equals to cos square alpha by sine square alpha is equal to cot square alpha. So this is our RHS. The question was very easy. So for next question, let's go to next page. Okay, now question number F, we can see that sec square a minus cosec square a is equal to tan square a minus cot square a. So again we'll be doing from LHS. In LHS it is given that sec square a minus cosec square a. So what we'll be doing, we'll be putting here formula sec square a and cosec square a. So we know that sec square a is equal to tan square a plus 1, or we can say 1 plus tan square a, 1 plus tan square a, and instead of cosec square a, we'll be using 1 plus cot square a, 1 plus cot square a. So instead of sec a, we'll be using this formula. Sec a is equals to 1 plus tan square a minus, because it is minus, we'll be put bracket open, and cosec square a equals to 1 plus cot square a. We have 1 plus cot square a. Now we will be multiplying 1 plus cot square a with minus. We have 1 plus tan square a minus 1 minus cot square a. Now you can see this minus 1 and plus 1 can get cancelled. So we'll cancel minus 1 and plus 1. So what we have remaining in our hand, we have tan square A minus cot square A. So remaining answer we have tan square A minus cot square A. So this is our required answer, is equal to RHS. Proved. Question was very easy. So we can easily say that sec square A minus cosec square A equals to tan square A minus cot square A. So for next question, let's go to next page. So this is our last question, because if we solve too many questions in one video, the video gonna be longer. So the next half I'll be putting in another part. Okay. So in question number G, you have sin square theta plus sin square theta tan square theta is equal to tan square theta. So it is very obvious that by solving this formula, this equation, we need to remove this sin square theta and also this sin square theta to get tan square theta. So let's solve it. From solution, in LHS, what is given over here? LHS, we have sin square theta plus sin square theta dot tan square theta. So in previous equation also we have taken common many times when we have similar terms in different equations. So we have sin square theta, and here also we have sin square theta. So we'll be taking sin square theta as common, and what is remaining in the hand? 1 plus tan square theta. Just in earlier videos we have discussed that sec square theta is equal to 1 plus tan square theta. So we have here 1 plus tan square theta. So instead of 1 plus tan square theta, we can use sec square theta. So sin square theta multiply by sec square theta. So and again we can use, instead of sec square theta, we have one more formula. Sec square theta is equal to 1 by cos square theta. So here instead of sec, we'll be using this formula. So sin square theta multiply by 1 by cos square theta. Now we will multiply sin square theta into 1. That is, we have sin square theta. In denominator we have cos square theta. And we know that tan square theta is equal to sin square theta by cos square theta. That is equal to tan square theta. So this is our RHS. Proved. So thank you. Only this much for today. So next half questions I'll be putting in another video. So keep watching. Please subscribe the channel. Thank you.